Next presentation is using the protocol to simplify PHY testing, a practical example with UniPro. Unfortunately, our speaker Victor Sanchez-Rico was not able to make it today, but stepping in for him will be Thomas Koff, Director of Marketing and Sales at BitifEye. He's been with BitifEye for the last 3 years and has been involved with MIPI ever since. So please welcome Tom Koff.
Can you hear me? Yeah, I think now it's better. So good morning, everybody. As said, it's Victor's supposed to be here, and instead of me, but unfortunately has not been able to make it up until now. So I'm trying to fill in and present his presentation. In fact, it was his development that he had been doing over the years. We're both from the company BitifEye. For those who are not very familiar with BitifEye, we are a German engineering company which is based in Germany, yeah. And we're 30 people, and we do care about receiver test solutions based on keysight instruments. Therefore, we are writing software codes for keysight instruments, for birds, for AWGs, in order to enable a smooth, correct testing setup. So the test automation software that we are developing is also distributed via Keysight as a N9590A solution. And therefore, we are very involved in various PHY test groups. So Victor is usually our main person to be involved for MPHY, and he will take over CPHY and DPHY soon, as well as a head development unit person. So we're going to go today in this short little presentation about the problem statement that we have, and we found a workable solution in order to go via UniPro Test Mode to a successful test setup that we had been already using in several UFS test events. So the problem is, as you can see here, that it's often challenging to do MIPI PHY tests. There is a lack of standardized and adopted test modes. The specs contain recommended test functionality, but they're rather informative, and therefore it requires the user to implement a DLL for test automation software to control the DOT and perform the tests. It also requires some out-of-band dot control capabilities. In that whole concept, and in the beginning of the UFSA, there was also a thought of loopback, which is there widely used, but as you all know, if we're really in a test event, loopback can be very cumbersome and time intensive. And there are some features which can't be tested with the standard equipment. So one of those things is the MIPI MPHY PWM, which we faced a little bit of a problem installing that on a bird. In fact, the Keysight bird is way too fast for this, and trying to slow it down to a PWM mode took a lot of coding, which in the end resulted into a pulse generation, which was getting at the limits of the instrument's memory. And if you defer that within the different gears, it's a solution which can be used, but it's something where we think, or we thought that there must be something else added to that in order to help with the PWM. And and to give an alternative on the manual reconfiguration of between those tests. So, yeah, I think I've covered the rest on this one. What we're looking at is the testing method, which is based on the UniPro test solution. So it's actually a protocol layer, but it helps simplify testing a lot. It has some requirements though. The requirements are in-band configuration of the DOT for each test. The DOT must remain in the test mode until it's explicitly disabled, and the DOT must implement counters, and it must be possible to retrieve them in-band. So once this is being implemented into DOT, it makes our life as testers more easy. We have a very defined way in order to go with the UniPro test. And we don't have the uncertainty of the sideband connections. So we have, for transmitter tests, we have to reset the DOT, config the test mode. I'm having troubles with the laser pointer. And basically test it by the scope. For the receiver, we are doing basically the same. Reset the DOT, config the test mode, but we're doing, of course, the testing with the bird with some, as long as and then we're testing or we're reading out the burrs. That's what I meant to say. So, in order to have our solution going, it's of course mandatory to have the UniPro test mode implemented. The test modes go through PCAP tests here, and it allows lane distribution settings. Single and multi-lane tests is possible with it. It can be configured transmission mode and speeds, and for RX tests we have implements frames and error counters, and we receive the error counters. The counters can be received by in-band through TX. The TX test, the DOT can be configured to transmit CR pattern for testing through the oscilloscope. So our solution that we wanted to talk about, and in fact, I think if you cross by the BitifEye booth by noontime, we will have a working DOT setup there for showing all the tests. It's a multi-lane test DOT, which we are able to show. It's something that will be qualified probably in 3 weeks from now on the next UFSA workshop, and it's a Silicon Motion DOT. We have been very happy to work with this company on our solution, and in the meantime it works really good. So they also use the UniPro Test Mode to test the physical layer, and it can be trained into the test mode. So with this, there are several gears, and we have to find out which gear is being used, and also the DOT needs to respond in the gear that is being defined. The UniPro counters are global. The test can set all lanes simultaneously to save time. Everything must be done inline, and no sideband connection is needed. and you will see it when you pass by the booth. It has little to no customization. So it's ideal, especially also for workshops. The hardware, we're using a scope for the TS text and the calibration of the RX. We have a bird standing there for the test pattern generation for the RX test. And we have a proto generator and analyzer which was developed from BitifEye for the device configuration and for the frame error counters here. So basically, the protocol generator will generate the PWM, so the low speed mode, so it does not have to go through the birds. It is connected with the bird and acting as a master via a switch. And so the DOT, why is that? The DOT is being put into the test mode by the PWM, and then the test will be preceded by the generator. So you can, as I said previously, you can use the scope for the TX test and also for the RX setup. And then you use the analyzer from our protocol generator in order to read out the bursts from the DOT itself. The whole solution does not only is a hardware solution. As you can guess, we're a software company and writing test automation software, so it would be strange if we're not having a software solution for it. It's also, as I said before, a test software automation which can be, which is a solution based on the N9590A framework. And it's possible for two steps. It has a frame generator, which is a debug software that we're offering. And it will help to define the DOT in itself. So when you're in the situation that you're in a test event and we'll have to test several DOTs, as we will be doing that on the UniPro test event in Thailand next Monday. We're probably faced with a lot of different DOTs which are set up individually, of course. And in order to get to the point how the DOT is reacting, we have been creating what we call frame generator, which is helping to adjust each PHY parameter individually. So basically, it's more of a tool which is being based on a high flexibility. So we're going to go into the DOT, see how it responds, and take all these learnings then into the RX test software, which then can be using all the settings that we have been learning through the frame generator in order to proceed the actual test. There is a test script wizard for automated test generation and to configure the patterns for each gear and each mode. And with that, you can also control the DOT configuration flow. And you will be able to receive the error counters from the DOT. So basically what you see here is that you can debug RX and TX. So you can change the coding or define the coding, the CRC type. You have a possibility to do UniPro scrambling and also retrieve counters. So here you can say see at the top of it, the frame counters have been received and no error counters to make sure that whatever we send to the DOT is being received well, and that we're able to see also what has been really sent to it and what has been a filler. We have a slider here that you can use in order to get the DOT error counter adjusted to what we read out. So basically, if it's adjusted right, you would see here fillers in black and the real codings that we had been sending through in blue. At the beginning, of course, this will be would not be showing up that way, so that's the ideal status of the symbols. And you can see here they captured UniPro, and you can verify that this what has been sent here matches with this one. And if this one is in sync, then you would have no error counters being stepped out here. And next step would be then to go to the to the test automation software. I was telling you we are also having then the test automation software basically. You'll see the green points here and very badly. Oh, okay, fantastic. Thank you very much. Yeah, that's better. So basically, that's the test tree. On a screen, you can see it a little bit better. It's not that faded out that well. The upper part is usually the calibration results. If you left the setup untouched, then you can all the time reuse those calibrations. The light green would indicate that it was passed well and that it was just freshly done with the calibration. Below here are the tests that are required by the UniPro test method and for the UFSA. And they are set up, and you are able to be proceeding those tests by pressing the button at the test software itself. It will run through. Ideally, there is for each test there is a protocol attached to it, which gives you the test results of each DOT, and you can store that individually per your DOT and take a look at it if you have variation from one DOT to another. And this is then all included in here. So we have different use cases that I want to talk right now. We have the receiver test case and we have the transmitter test case. In the receiver test case, the DOT data is connected to the switch. The data 0 is connected to the switch, that they can alternate between the pattern generator and the protocol generator. The DOT data 1 to 3 RX connected directly to the pattern generator. The DOT data 0 TX connected with the protocol analyzer, and a DOT RST and also connected to the test mode. Test flow is, as I indicated previously, the automation connects the protocol generator to the DOT. The hardware is reset to the RSTN of the DOT. The protocol generator sends the link configuration pattern to the DOT. The automation connects the test pattern generator to the DOT. The test pattern generator sends the pattern to the DOT, interleaving frame and error counter requests, and DOT responds. The analyzer captures it, and the test automation decodes it. The test goes on until the DOT reports errors or a target burr is achieved. Likewise, we have a slide for the transmitter test. So here the DOT data 0 RX is connected to the generator. The DOT TX line is under test connected to the oscilloscope. The RSTN is also controlled to alternative test mode. The protocol generator sends hardware to reset the DOT, the protocol, and it sends the link configuration to the DOT, and the automation controls the TX test software and to run the selected tests. As I said, from noon, I would say, you can watch the live demo at our booth. Then also Victor is available. As I said, he had been working over years on this one in order to develop it nicely, and he will be very proud to show you the test setup and answer all your questions that you might have on this one. Again, apologies that Victor could not be here and that I have to fill in. It's probably not as in-depth as you have been expecting it. I hope that nevertheless there was some value for you in this and that it would make you curious in order to come by at the BitifEye booth later on.